Welcome to Software Quality Now. My name is Steve, and on this channel we focus on the development of high-quality, mission-critical software. In today's video, we're going to look at 5 issues for projects that deliver high-quality, mission-critical software solutions. High-quality software is software that the customer perceives as delivering the value expected. A mission-critical software system is one that is required for the functioning of an enterprise. The development of a high-quality, mission-critical software solution can be difficult. Very difficult. So difficult that a high percentage of these projects either fail outright or fail by a wide margin to meet expectations. The systems resulting from these troubled efforts typically have low quality. They don't do what they're supposed to do. They have latent defects. They have bugs. Usually lots of them. If that's not bad enough, these projects take longer than expected, require more staff, and use unexpected resources. By the way, this is not a new problem. It's as old as software development. But why does it continue to occur? Every failing project fails for its own reasons. However, here are 5 issues that I've seen repeatedly throughout my career. Issue number 1, not just coding, or it's not rocket science. Around 20 years ago, a CFO remarked in a derisive tone, "Software development isn't rocket science." I responded, "Actually, rocket science is easier." This exchange between myself and that nameless CFO points to one of the factors contributing to the difficulty of doing software development. That CFO did not understand software engineering in any detail and equated coding with all the work necessary to deliver a high-quality, mission-critical software system. Coding was reasonably straightforward 20 years ago, and it's gotten even more so since then. Modern programming languages like JavaScript and Python, modern development environments, and the seemingly infinite resources available on the internet all contribute to this. The impact of generative AI may rock our world in ways we are only now beginning to appreciate. That CFO didn't understand that any reasonably complex mission-critical solution requires applied expertise in a number of different software engineering disciplines, with coding being only one of those disciplines. A customer without a reasonable understanding of this may have unrealistic expectations about staffing, levels of effort, required resources, the length of time needed to complete delivery. This leads to customers demanding delivery in unrealistic timeframes and with inadequate budgets and staff. The typical result is either the failure to deliver a system or the delivery of an incomplete system that is buggy, poorly tested, and inextensible. Issue 2, incomplete and insufficient requirements. Or, it would be a great job if it wasn't for the customer. So, we've established that customers often have unrealistic expectations about the work required to deliver a high-quality, mission-critical system. At least they know what they want the system to do. When asked, the customer gives the engineering team a complete and concise description of everything the engineering team needs to know. Are you laughing? Really? Stop laughing. All right, the joke's on us. Getting effective requirements is difficult and time-consuming. The problems include, first, what the customer says they want is often different from what the customer really needs. Customers often express requirements in terms of a solution. This tends to obscure the underlying needs. Second, the requirements are ambiguous and do not contain the requisite detail to allow the system to successfully meet the customer's incompletely expressed expectations. If that's not bad enough, the customer has no more time and thinks that everything else should be obvious. Third, a customer naturally focuses on the functionality and neglects to consider non-functional requirements. The non-functional requirements are operational characteristics like efficiency, security, reliability, etc. Fourth, a customer's different stakeholders may each have a unique, competing, and contradicting perspective. Fifth, the sheer volume of requirements leads to challenges with capturing, analyzing, organizing, prioritizing, and validating all those requirements. Sixth, the scope of the system may be excessive, resulting in higher costs, levels of effort, and delivery timeframes. Seventh, inevitably, the requirements change, often as soon as the first tangible deliverable is produced. Eighth, and finally, people often don't accept change easily. They claim to want change if it means they don't have to do anything different. All in all, this is a lose-lose situation. The customer doesn't get what they imagined they would get when they initiated the project, and the delivery team fails to deliver a system that meets the phantom requirements. Issue 3. Poor planning, or failed to plan, plan to fail. Imagine you are building a house and you are going to act as your own contractor. You've never done this before, but how hard can it be? You've closed on the piece of property. You know the kind of home you want to build and the features that are important to you. And you've arranged for all the subcontractors that are needed to build your new palace. Your significant other has only agreed to this because of the amazing second floor gym you've promised. Given the clear importance of this, you decide that this is where construction should begin, on the second floor. Now, this story is ridiculous. We all could see this because we live in the physical world and we have some grasp of gravity and how construction works. Unfortunately, software engineering is a relatively young endeavor, and we all don't necessarily have an intuitive grasp of the decisions to be made and the order in which they should be made. As discussed in issue number 1, high-quality, mission-critical solutions require the successful application of multiple disciplines, along with precisely choreographed activities and decisions. Software engineering is all about making lots of different decisions in many different disciplines. Failure to do the right thing in the right way and in the right order can lead to latent defects and ultimately issues with the project schedule and cost. When building a house, you rely on blueprints, strong, experienced leadership, detailed plans, and proficient tradesmen. Delivering high-quality, mission-critical software solutions is no different. Issue number 4, testing quality into a system, or taste just one more cookie. Testing software is a lot like taste testing a batch of cookies. If there's something wrong with that cookie dough, no matter how many cookies you taste, the result will be the same. I remember one of my children wiping off her tongue when tasting something bad. That doesn't work so well when you are testing software. There's no doubt that testing is vital. Often testing gets cut back when a project is late or is having budgetary problems. When that happens, the defects don't go away. They will probably be found by the customer. The flip side of this is that quality cannot be tested into a software system. Ideally, testing should be a formality that identifies only a few defects. And the longer a defect is latent in the system, the higher the cost to eradicate it. A project that has logged a lot of defects during testing probably was troubled from the very beginning. Issue number 5, poor maintainability, or, but it's just a small change, or write-only software. It's not all doom and doom, of course. We do deliver software solutions, and our customers use them to conduct business. Inevitably, these systems require changes. These changes come in 3 categories: a previously unidentified latent defect, adaptations due to changing requirements, and an enhancement or extension to the functionality of the system. Why then is the customer shocked and unpleasantly surprised regarding the time required and cost associated with making these changes? Several possibilities impact the software system's cost of maintenance. There's a direct relationship between the complexity of the system and the cost of making a change to that system. A certain amount of complexity is inherent in the problem domain, and the complexity of the implementation itself adds to the overall complexity of the system. However, unnecessary complexity can increase the cost of making changes unacceptably. Technical debt also impacts the cost of maintenance. A certain amount of technical debt is inevitable when building any reasonably complex mission-critical solution. Technical debt, intentional and otherwise, can have a profound impact on maintainability. Another reason for unexpected maintenance cost is the continued use of systems that were intended to have a short lifespan but are subsequently maintained and used long past their expiration date. I designed a billing system once that was replacing a legacy billing system that had been in use for over 20 years and was no longer able to keep up with the production of monthly invoices. Staff familiarity with the system and how it has been implemented has an impact on maintenance cost. Often the least experienced resources are assigned to maintenance activities. As software undergoes maintenance, the complexity and disorder within the implementation will increase unless there is a conscious effort to avoid this. The use of less experienced resources magnifies the level of complexity and disorder injected into the implementation. This, by the way, is known as software entropy. Conclusion: I met the enemy and they is us. Who is to blame for these 5 issues? It's certainly not the customer, as momentarily satisfying as it might be to blame someone else. The reality is that we are responsible for these problems. From the beginning, we need a mature software development process that is tuned specifically to the nature of the problem domain and the circumstances. We need to open lines of communication with the customer and within the software development team. And we need flexibility in order to adjust to the inevitable changes. This is Steve. Thanks for watching. Don't forget to like, share, and comment. And subscribe so you don't miss any upcoming videos. Your support makes it possible for me to continue making these videos. See you for the next video on the Software Quality Now channel, where we focus on high-quality, mission-critical software development.